Hello and welcome to the first recording for this O-level math series. I am starting off with chapter 1. This series should help you understand the entire topic. This is relevant from grade 8 onwards if you are in a Cambridge school and doing O-level math. This should be your starting point. I will combine all the chapters with past paper questions. There will also be marathons later on once I complete the syllabus. So let's begin. The first chapter is called Understanding Numbers. First, we understand what we call directed numbers or directed numbers. Okay, I am pretty sure everybody must have seen a number line by now. On the right hand side, numbers become positive. So you have 1, 2, 3, 4, and so on. Okay, and on the other side, numbers become negative. So numbers with either a minus sign or a plus sign. If there's no sign, you say that it has a plus sign. Okay. Numbers to the right hand side of 0 are positive, and numbers to the left hand side of 0 are negative. Directed numbers are numbers that can be positive as well as negatives. The sign indicates a direction. For example, minus 10 is 10 degrees below freezing. Freezing is when you have 0 degrees centigrade. So minus 10 is to the left hand side of 0. Okay. So we're going to use this number line and answer this question that I have in front of you. This says the temperature starts at -5 and rises by 4 degrees. So what you do is you jump 4 to the right and you end up at -1. It's simply -5 plus 4 that gives you -1. Okay. The temperature starts at -1 and falls by 2 degrees. So you go backwards because it's falling. Okay, that would end up you would end up at -1 -2, which is -3 degrees centigrade for the second one. For the third one, it says the temperature starts at -2.5, so it's somewhere here and rises by 5.5. So what I can do is I can first run this 0.5 and then go 5 forward. 1, 2, 3, 4, and 5. So I will end up at 3 degrees centigrade, or you can just simply tell you that's -2.5 plus 5.5. If you know addition and subtraction well, you would subtract this. Okay. Part B, for example, 1 says which is warmer, 2 degrees centigrade or -5 degrees centigrade. So obviously -5 degrees centigrade is less than 2 degrees centigrade. Uh, so it becomes colder when you are to the left hand side of the temperature. So in this case, 2 degrees centigrade is going to be the warmer temperature. Okay. Then, as I've been adding and subtracting, a more formal explanation for calculating with directed numbers, you might be asked to add or subtract directed numbers. For example, you can see that I'm asking you to add a positive 3 to this, or I'm asking you to subtract a negative number from this. Okay, this says we must take care when we calculate with positive and negative numbers. With addition and subtraction, we need to know what to do when a plus or a minus operation appears next to the plus or minus sign of a number. There are two examples of correct calculations. Okay, so you see a plus and plus gives you plus, so this becomes 12 plus 3, which is 15. A plus and minus gives you a minus. Okay, so 12 plus minus 3 means 12 minus 3, and that gives me a 9. 12, a minus and minus gives plus, so 12 minus minus 3 becomes 12 plus 3, and that gives you 15. And a minus and plus give you a minus, so 12 minus 3 gives 9. Generally, with addition and subtraction, the combination of signs determines the direction of resulting operation. Here, um, um not red and black for you, but I can tell you that red indicates an operation and black indicates. So these were supposed to be red, although I haven't changed the colors before. Okay. Okay. With multiplication and division, the combination of sign of two numbers determines the sign of the resulting number. Okay. So you have to see what two numbers are being multiplied and whether each of them has a positive sign or a negative sign. Okay, we'll come up with rules for this as well. Here are some examples of correct calculations. Let's see what this says. It says generally for multiplication and the division, the resulting number is positive when the signs of the two numbers are the same. So you see 12 into 3 gives you 36, and minus 12 into minus 3 also gives you 36. Okay, 12 divided by 3 gives you 4, and minus 12 divided by minus 3 gives you 4 as well. Negative when the sign of the two numbers are different. So when you have different signs, so 12 into 3 gives you minus 36, or minus 12 into 3 also gives you minus 36. Similarly, 12 divided by minus 3 gives you minus 4, and minus 12 divided by 3 also gives you minus 4. Okay, this is a past paper question from the IGCSE paper from June 2004, a relatively old paper for you, but question is still relevant. The Dead Sea shore is 395 meters below sea level. Hebron is 447 meters above sea level. So the sea level works in the same way that a number line does. It's just that it's vertical. So 395 meters below. So can I say that this is minus 395? And 447 is above. Okay, so that's Hebron. And this is Dead Sea, shore. And this is sea level. Okay, let's call that 0. Find the difference in height. So I can say that if I want to find the difference in height, it's going to be 447. For difference, you put a minus. And what do I want to subtract? I want to subtract minus 395. That becomes 447 plus 395. Now, in the older papers, you were allowed a calculator on such questions. But in the new IGCSE syllabus, you won't be allowed to do that. So let's add manually. And 13, 14, and that gives you 5 and 3, 8. Okay, 842 meters is the difference in height. Okay, example number 3. The same records the temperatures in degrees centigrade at 6 a.m. every day for 10 hours. Minus 6, minus 3, 0, minus 2, minus 1, minus 7, minus 5, 2, minus 1, and minus 3. Find the difference between the heights, um, highest and the lowest temperatures. So let's first figure out what the highest temperature is. Something with a positive sign, and that's a big number. The only number that I see is 2. So the highest temperature is, I should use more friendlier colors. Okay, highest temperature is 2. What is the lowest temperature? Let's figure out the lowest temperature. I can see a minus 7. Yeah, that should be the lowest temperature, minus 7. So what is the difference? 2 minus minus 7. And like I explained before, two negatives become a positive. So that becomes 2 plus 7, which becomes 9. Okay, so the difference between the highest and lowest temperatures is 9 degrees centigrade if I want to write the unit as well. Okay, that is about directed numbers. Directed numbers are numbers with signs, and you can add them, subtract them, and so on. Okay, next, a follow up to this is in order of working in calculations. So you can have multiplications, divisions, addition, subtraction, everything in there. We've now different books will have different acronyms for this order of operations. What I will use is word mass that we've been using for years and years. I learned it the same way, so I would want you to also learn it the same. Okay, it says when a calculation involves more than one operation, we use word mass. Brackets are worked out first. Okay, so if you have a bracket, you work them out first. I'm going to show that to you when I'm doing the calculations. Then the order of operations, so B a bracket and then order of operations is D mass. D mass is division, multiplication, addition, and subtraction in the order that they are written from left to right. Okay, so we have to follow this rule. If there's a bracket, let's resolve that first, then do division, then multiplication, then addition, and then subtraction. Okay, so let's look at this first one first. A, you have 4 plus 3 into 4 plus 3 into 10 minus 6 divided by 2. According to the rule, I don't have a bracket. So what I'm going to first do is do division first. So this becomes 3. So this becomes 4 plus 3 into 10. minus 6 divided by 2 is 3. Then I should do a multiplication. So this becomes 4 plus 30 minus 3. Then I should do my addition. So now with additions, you should remember that there are two numbers with positive signs. Okay. So that's plus 4 plus 30. That gives me 34 minus 3. Now, on the way, you can become quicker at this. You don't need to show me all the steps that are there. I'm just showing you because this is a lecture series. On the exam or marathons, I will probably be doing these much more quickly to show you what the order of calculations is. Okay, let's first resolve this bracket. So 7 into 10 minus 6 plus 2. What should I do first? I should do multiplication first. So 70 minus 6 plus 2. I should add first. So 72 minus 6, that gives me 66. To the next one, C. 4 plus, let's resolve the bracket, 30. Okay. And then I can also do the division. 6 divided by 2 is 3. Addition first. 34 minus 3, that gives me 31. For D, 4 plus 3 into 10 minus 6 is inside a bracket. So 4 and then plus 2. Again, multiplication first. So 4 plus 2 plus 2. 12 plus 2, all of these are being added together, so 12 plus 6 is 18. Okay, now on the new syllabus, you're not allowed to calculate on the first paper for both IGCSE and Olevel Math. So be careful with the calculations. You cannot verify your answers. You have to make sure you get them right in the first go. So I've added up the brackets first, 7 and 4. 7 into 4 gives me 28, and then plus 2, that gives me 30. Okay. Okay, now inside the bracket, there's also a series of calculations. What should I do first? I should do the multiplication first. Okay, I've done the multiplication first, then I still resolve the bracket first. Then 24 divided by 2, that gives me 12. And the final answer is 60. Okay, so these were all the calculations for BODMAS. Okay. Example number 5. It says put brackets in the right places to make each of these sums correct. Okay. Now this is a typical, why don't we do example 6 first and then we'll come back to example 5. Example 6 is a past paper question. So and this is just one of the attempts. So I'm just going to show you that first. Now remember that you have to put in brackets to make these calculations correct. Now there's no set way of doing this question. You have to use a bit of trial and error and come up with sort of mental calculations or what could have been the case that it divided and then multiplied and so on, and you sort of got to the correct answer. Okay, so what is going on in my brain is that if I do 72 divided by 4 first, let's say I put the brackets in here first, that will give me a very large number. I'd probably be at 72 divided by 4 should give me around 18. Okay, then 18 into 2 will give me 36. I don't want 36, I want 10. Okay, so I've got to come up with a smaller number, which means that I must divide 72 by a bigger number to reach a smaller number. What is going on in my brain is that, can I put a bracket here? I'm not putting a bracket on 1 and 72. Why? Because that's going to give me 73. Odd numbers are difficult to divide. We'll talk about that. Um, but this sort of is giving me a reasonable bit of calculation. So let's see if I get my correct answer. Let's see, 72 divided by 8. That gives me 9 and that gives me 10. So yeah, I've reached my right answer. So where should I put the brackets? I should put the brackets here. Okay, that I need to multiply 4 and 2 first. Okay, there are several others that you should calculate with me. Now you see, I need in part A, what I need is I need a very small number. I need a positive number, not a very small number. I need a positive number. If we put a bracket here, this becomes 5 minus 12. That would give me negative 7. So that doesn't work out. Where should I put the bracket instead? I should put the bracket instead at this point. and say that this becomes 2 into 4, 8. Okay, so with the brackets here. Okay, I think I may have missed a sign here. Let me check. Okay, I think there's a typo here, and this should be a divide sign. Okay, a little messed up, but this should be a divide sign. Okay, because I can't seem to get the answer out of it. Okay, so 9 plus 50 minus 24 divided by 2 equals to 22. And it's sort of obvious here that if I add these two up first, it gives me 59. So there's something else that's going on. If I divide these two, it also gives me a very large number. Then 50 minus 12 still gives me 38. That's still a very large number. So where I should put the brackets is here. What it becomes is 9 plus 26 divided by 2. That becomes 9 plus 13. That gives me 22. Okay. Again, bits of trial and error. You will learn on the go. There's no set way of determining where I can put the sign, but that's what the question is about. Put the brackets in the right places to make. So you do trial and error and sort of figure out where the right place is. Okay. Okay. So 31 minus 15 divided by 10 minus 2. That's a tricky one because if I divide these two first, I end up with 1.5. Then 1.5 I won't be able to divide this. What is happening here is I think I need to put brackets in two places because I see the 16, I see this as an 8. That gives me 2. Okay, so the right place for the brackets is here and here. Okay. Okay, then we have this was directed numbers. Then we did a bit of calculations. Okay, you must remember all of these. They're going to come in handy again in algebra. What we're doing now is types of numbers. Let's talk about types of numbers. You need to remember the categories of numbers because it's going to be tested. I'm going to show you some past paper questions here, and then we can talk about other things as well. I think there's a past paper question here. Okay, it's going to come up later on, but yeah, I think this one, that example 9 is a past paper question, or I don't remember exactly, but there are many questions like that. Um, you will see those coming up. This is relevant to again paper 1 where you don't have a calculator. Okay, uh, the numbers that we use for counting, measuring, and calculating are so many that it is impossible to know how many are there. Infinite number of numbers. The number of numbers is not countable. However, we can organize these numbers into groups or types that have certain properties in common. Okay. The first category that I want you to remember is natural numbers. Natural numbers are also called counting numbers. Okay. Let me write that down for you. Also called counting numbers. Okay. What do you count with? You count starting from 1. So 1, 2, 3, 4, 5. All of these numbers is counting numbers. A natural number is even if it can be divided by 2, otherwise it is odd. Okay, so 1, 3, 5, 7, 9 are odd numbers. 2, 4, 6, 8, 10 are even numbers. 0 and all negative numbers are whole number, and all positive and negative whole numbers are integers. Okay, so if you add negative numbers and 0 to this set of natural numbers, what is that category called? Integer. So integer is just a whole number without a fraction, without a decimal, and that's what integers are. Okay. Another category to remember is a square number. Square numbers are also called perfect squares. They're also called perfect squares. Is obtained by multiplying an integer by itself. So 3 square gives you 9, so that's 3 into 3. What are the square numbers? So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, and so on. Ideally, you should remember these up till 20. Okay, I can write these down. 20 square basically. Um, I should write these down for you, in fact. So that's 13 square, that's 14 square, that's 15 square, that's 16 square, that's 17 square. Let me just check if I've done this correctly. Yeah, I done this correctly. Um, 3, 4, 61, and 400. Okay, so you should remember this list up to 20 squares. Similarly, when you take these perfect squares and you square root those numbers, square root is a number that can be multiplied by itself to make another number. For example, the square root of 9 is 3. Why? Because it can be broken up into 3 and 3. So this is written as root of 9 equals to 3. If there's no, it's just this sign, it means it's a square root. On the other hand, if you see this, I'm sure you've done this, this is called a cube root. Okay, same goes for cube numbers. For squares, you were multiplying twice. For cubes, you will multiply thrice and you will get your cube numbers. Again, you should remember your cube numbers up till 10. They're written here. That's 1 cube, 2 cube, 3 cube, and so on. Okay, comes in handy when you're solving questions. Okay, the reciprocal of any number p over q is q over p. For example, 2 over 3 is the reciprocal of 3 over 2. When you exchange the numerator and denominator of a number, you end up with the reciprocal of a number. The important property is that the product of a number and its reciprocal is always equals to 1. So you multiply any number with its reciprocal. If you've done a bit of multiplication, you should know that these cancel out. You end up with 1 over 1 or 6 over 6. That's equals to 1. Okay. Rational numbers are important categories. Anything that can be expressed as a fraction. Anything that can be expressed as a fraction. Okay, can be expressed as a over b, where a and b are numbers, such that 7 equals to 7 over 1, 1.5 equals to 3 over 2, and root of 25 over 3 equals to 5 over 3. All of these are expressed as fractions, therefore they are rational numbers. Then there must be numbers that cannot be expressed as fractions. You should try to remember these. Irrational numbers are those that cannot be expressed as a over b, where a and b are integers. So pi is something that you can't express as a fraction, although you might have seen that it's all sometimes written as 2 over 7. But remember that 22 over 7 is an approximation. It's not the exact value of pi. You can verify with your calculators and you will see that pi is basically an irrational number that cannot be expressed as fraction. Okay. Root 2, root 3, root 5, all of these are irrational numbers. When you even use your calculator to calculate these, the calculator refuses to convert this into fraction. I can show you this on my calculator, hopefully. Let's open up my calculator. Okay, I'm just opening up my calculator so that I can show it to you. Okay, so if I show you 22 divided by 7, do you notice that the decimal number is 3.142857? If you compare this to the actual value of pi that's stored in the calculator. 3.14287 and see this 3.14159. So there's a wide difference between that. If you put root 2 on your calculator, you see it just shows root 2. You can convert to a decimal but can't convert to a fraction. This tells you that root of 2 is also an irrational number. Okay. Okay, now how would you be asked these in a question? You will be asked to do these in this way. I can ask you from the list given above, select the natural numbers, counting numbers. So what can you count with? You can only count with positive whole numbers. So that's 2 and 2005. What are the integers? 2 is an integer, minus 99 is a negative integer, 0 is a neutral integer, and 2005 is a positive integer. What are the natural numbers? Ones that are expressed as fractions can be expressed as fractions. 1 over 1000. 2 whole 1 over 2 is also a fraction. Minus 1 over 4 is also a fraction. Point 0.3 can also be expressed as a fraction. 0 can also be expressed as a fraction. 0 over 1. And you can say 2005 can also be expressed as a fraction, and 2 can be also expressed as a fraction. Okay. What are the irrational numbers? Root 3 is irrational. Pi is irrational. Real numbers. All numbers are real numbers. Only what are non-real then? You will study this when you do A-level math. For example, root of minus 9 is a non-real number. It's also called a complex number or an imaginary number. Okay. That is it for this lecture. I will continue with prime numbers, factors, and multiples in the next class, and then carry it on to prime factorization and so on. That will complete the chapter. But for now, this is the first lecture for this chapter. I will show you past paper questions and marathons later on. Thank you for watching.